So a couple announcements before we get into the material for today. In an effort to get the test returned to you essentially the day after you took it, everything else kind of got put on hold, and now we've been playing catch-up with that. So we do plan on returning the lab quiz soon and homework 3 soon, and getting things like the lab, the exam grading guidelines and the regrade form out. That should all be out on Wednesday. I know I said I'd have it by today. I guess I kind of lied. Sorry about that. We are planning on getting that soon. It's just, well, basically I had to put my other class on hold so I could get the test out to you on Thursday, so then I had to play catch-up on my other class. Once we return the lab quiz and the homework, about 25% of the final course grade will have been determined. The test is worth 10%. The labs we've gotten so far are worth about a total of 5%. The lab quiz and the 3 homeworks are another, say, 12% or so. And of course, that weighting is displayed in the view grade script. Remember that the final course grades for cs101 are determined on the 10-point scale. So 90 above is an A, 80 above is a B, 70 above is a C. So that should give you some idea of how you're doing in the class. And the reason that obviously all of you had the test in this class last week, but also probably in your other classes, is the drop deadline is Wednesday. So we basically do that so that you have some idea of how you're doing, so you can decide whether or not you do want to drop the class. I hope you don't, but obviously that's your call. So assignments, the 4th homework is out. It is due this Friday. That's the flow chart with ifs. The 5th homework will be out. We've actually pretty much written it. It's the card game War. But I don't know if we can call it war, so we might be calling, well, I was thinking we could call it love, but I thought I'd get in trouble for that as well. So I think we might call it peace. But regardless, that's going to be the homework. It's mostly written. We just need to do some checking. I'm going to spend some time going over it on Wednesday, because Friday there's not going to be any lecture. Because, let's face it, how many people would actually show up at 3 p.m. the day before spring break starts? Yeah, exactly. So you notice, like those who are staying for the game the next day, they're going to be there. But in all seriousness, the material that I would start covering then, did I miss something? Oh, the material that we would start covering then is going to be is fairly important, and I don't want to start with a lot of the class missing. Here is a question: would those people like me to have a small sort of question and answer type period where you show up and ask any questions that you have, sort of like a review session instead of a lecture? Who might like that? Okay, there's some. So what we'll do is I will be here at 3, along with about 5 of you, and bring any questions you have. I'll happily answer them. Realize that at 3:05, if nobody shows up, then I'll probably head home, or at least back to my office, which is kind of like my home. So if you show up at 3:15 and this place is empty, that's why. So there is lab this week. Going home for spring break, if you are going home early for spring break, because I know some people are bolting on like Wednesday, if you are going home early for spring break, we can do a makeup lab, but you've got to email us ahead of time. Missing the lab because you went home early for spring break and not telling us ahead of time means a 0 for that lab. So please email cs101, that's the bottom line, if you are planning on traveling early for spring break. Let's see what else. So clickers. The clickers seem to be working. We're going to be using them today. And once we start getting into some of the material we're going to see after spring break is actually really why I wanted to start using the clickers. So everybody will need to have a clicker and to have the clicker registered by after spring break. In particular, when you register your clicker, you have to enter the serial number. I promise you that that is not your serial number. R4W, RC, RF01. Everyone look on the back of their clicker and raise your hand if that number is on the back of your clicker somewhere. It's this, exactly. So the point is that most of you have that number on the back of your clicker. That's actually the product number. The serial number is 6 letters or numbers. 0D, 0F, A, C. I don't know, something like that. So that's actually the number that you need to enter. I'm going to be emailing everybody individually, probably after spring break, if your clicker is not properly registered. Either there's nothing there or you've entered the product number. So please, when you get a chance, get a clicker, register through the toolkit. We're going to be talking about something called the halting problem, which we're probably going to see right after spring break, because I don't think we'll get to it on Wednesday. And that in particular, I'm particularly excited about using the clickers for. Okay, other questions, comments, concerns? All right. So in the highly attended class last Friday, we were talking about while loops. And remember what a while loop is. It's some section of code, generally a block separated by our pretty curly braces. And essentially, Java will test to see if that condition is true in the parentheses. If it is true, it executes the loop. And then it will check the condition again. And it will keep executing that block of code while the condition is true. Once the condition becomes false, then it will no longer execute that particular block of code and continues on afterwards. And this was the second to last, well, this is the last real slide that we saw last time. This was the reading in from a file. So remember that a while loop looks kind of like an if statement, except instead of an if, it's a while. The Boolean expression must evaluate to either true or false is in parentheses, and then it's either one line or multiple lines separated, enclosed by curly braces, and that's what the loop does on each iteration, each time it goes through. Okay, right? We already talked about that. I demotivated you properly. Okay. So while loops are one of three different types of looping mechanisms that Java provides. It turns out that all of them are actually pretty equivalent. But as we're going to see, some of them are easier for us to, generally programming, of course, is taking your thought process and forming it into a computer program. And some of the loops are better for certain thought processes than others. We're going to see some comparisons as to which is which. But ultimately, all of them are equivalent. Some of them people find easier to use than others. Next up is the for statement. The for statement looks like this. Notice that it's kind of like an if and a while, in that you have the particular keyword, for, and something in parentheses. But you'll notice in parentheses, there are three parts separated by a semicolon. This is unlike an if or a while, which just has a single Boolean condition. And I'm going to get to the part in parentheses, because that's kind of what makes up the for. We still have the block of code separated by our favorite curly braces. In particular, the first part of a for is called the initialization. That is done at the beginning of the for loop, once and once only. So before the for loop ever starts up, that particular segment is executed. And that essentially consists of, okay, which color? Pink? Pink. I think that's pink. That's the initialization part. You'll notice that here we have one of our semicolons. This is the while of the for condition. It operates just like a while condition. It must evaluate to a Boolean value, and while it is true, this loop will keep going around. So that is exactly like a while loop. Then it executes the body, which is either, again, a single statement or multiple statements separated by or surrounded by curly braces. And then it executes the for update. At the end of each body, it will execute this last part there. And that basically is, think of it as getting ready for the next particular loop. So what happens here is that as we are executing this, come on, there we go. First what it's going to do is declare an integer I, set it equal to 0. It checks to see if I is less than 5. Well, 0 is less than 5, so it's going to execute the body. It's then going to do a plus plus I. Remember, the for update is done at the end of each loop body. It does a plus plus I and then starts all over again. At that point, I is 1. 1 is less than 5. That evaluates to true. It executes the body, increments I to 2. So this loop is going to go through that particular body a total of 5 times. Now, I've thrown that at you kind of fast. I'm going to spend the next couple slides explaining that in more detail. Here we have our favorite flow chart. In particular, The for init is done first. It is done once and once only. So we're coming down, doing that. We do the for expression, meaning check to see if that is true or not. It's just like a while expression. If it is false, or any time it becomes false, we then just keep on going to whatever code is down beneath it. Assuming it's true, we then execute the action, which is the single statement or one or more statements surrounded by curly braces. And then we do the post expression, which is also called the for update. Right. Everything I just talked about. This is another way to look at the for loop. Again, it has the same parts. The for init is done at the beginning. That's the Boolean expression. Every time, if that is false, then it won't execute the loop. And that's done at the end of the body. The body, of course, being the action. The other thing to keep in mind here is that even though there are 3 parts of a for loop, there are only 2 semicolons. The semicolons separate the parts. You don't need a semicolon after the for update. And if you stick one in there, Java's going to get very confused. So there's only 2 semicolons, and that just tells Java where you separate the for init from the for expression from the for update. So a for statement is kind of like a while statement. I told you that they're all kind of equivalent. And here we have that particular nicely coded for statement. We have the thing that's done once and once only, the Boolean expression, the thing that's done at the end of each loop, and of course the body. We could translate it to a while loop that looks just like that. Notice that it first does the for init into I equals 0 or anything that you want. It's a while loop based on the blue part because that's the Boolean expression. It does whatever is included in the body, which is the action part. And after the body is done, meaning after it's finished executing, then it's going to do the for update part. So for the most part, we're going to see one difference when this isn't the case, but for the most part, any for loop can be translated into a while loop just by rearranging it this way. Yes?
Just as a side note, can you put the while expression after the parentheses?
In here? So the question is, can you put the while expression after the parentheses? In a while loop, it needs to be in this particular format, but there's something called a do while loop, where the while loop actually, the keyword while comes after the body. We're actually going to see that after the for loop. Okay, any other questions so far? All right. So as I said, they're pretty close, but there's 1 or 2 times when they're different. So here we have a while loop that, in particular, you'll notice that this will always loop forever. In that, this says while true. Well, when is that Boolean expression ever going to be false? Obviously, it's not going to be, since we said while true. This particular program or program segment is called an infinite loop, meaning once it starts executing that loop, it's going to keep looping around forever and ever and ever until you hit Control-C or tell the program to abort or something like that. This program will never terminate. It will never halt. And I mentioned before that I'm going to talk about the halting problem. It actually deals with what are called infinite loops. In particular, this program, it'll never actually get to this print statement because you're never, I mean, every time you test a Boolean condition, true evaluates, not surprisingly, to true. So we talked about variable declaration before. In particular, we've talked about variable declaration inside a main method. You know, int n equals 7 or something like that. And it's visible inside the entire main method. Well, I want to generalize that a bit. Anytime you declare a variable, it is visible within the block that it is declared. So here, this variable, int n is equal to 0, is declared within that block. Right? It's obviously within that block. So that variable is visible until we hit the closed curly brace. So that variable is not going to be visible outside that particular block. So what happens is this loop starts up, it says int n equals 0. It creates a new integer variable n, sets it equal to 0. The second line in the loop increments that and makes it 1. And then it prints out 1. At that point, it starts all over again, right? Because while true, so we're going to start all over again. And it recreates that integer variable n. So it forgets about the original n it created and creates a whole new one, setting it equal to 0. Increments it to 1 and prints out 1. The loop starts up all over again, creates the new n equal to 0, increments it to 1, and prints out 1. This variable n will never get to 2, because every time the loop starts all over again, it recreates the variable, adds 1 to it, and then prints out 1. I saw a hand go up. Yes?
So, 1 minute, it doesn't give you an error statement because you're initializing n again and again?
The question was, does it give an error statement? Ignoring this line for a moment, this does not give you an error statement. There actually are times when you would want to declare a variable inside each loop. Essentially what happens, I think the best way to answer the question, because this variable was declared inside that block, when the block ends, which means when you actually hit that closed curly brace, Java then deletes that variable. So then it can be recreated because there isn't an int n already. So it creates it inside the block, so when the block ends, which means when you hit the end of the loop, it deletes the variable. When it starts all over again, there's no n that exists because it was just deleted. So not counting the very last line, which will cause a problem, that code will not give you an error statement because it creates the n at the beginning of the loop body and then deletes it at the end of the loop body. Okay. How many people so far feel they understand this code? I'm not seeing many hands. Is the variable thing confusing? Okay, how many? All right, everyone get up and stretch. Come on. Everyone stand up. You can do it. You can do it. Come on, up and stretch. It's only Monday. Stretch over this way. And then over that way. And then forward. Okay. Okay, so I'll get to your question in a second. How many people feel they understand this section of code? Okay, I'm seeing some more hands. Question. I'm sorry, can you say it a little louder?
It's like system.out different line, you're putting n, and then it closes and prints it again.
What's the purpose of doing this? The purpose of this whole code is to show you how something works. All this code will do is print an infinite number of ones, which obviously is not particularly useful in terms of just printing a number of ones. But what I'm trying to show by this code is the fact that at the beginning of this while loop, at each time this while loop starts, it creates an n. Each time it ends, it deletes that n so it can recreate it again. So no, there is no real purpose. I mean, no one really needs a program to print lots of ones. Well, what I'm trying to show by this is the concepts of creating the variable and deleting it. Okay. Other questions, comments, or concerns? I'm happy to explain this more. I want to know what is confusing you the most. How many people feel a little bit shaky on the whole creation and deletion of a variable part? Okay. This is why I need the clickers. All right. So let's look at this code, which is fairly similar, except the difference here is that instead of a while, it's an if. If you can create a variable inside any block, and what happens is this if starts up. It says if true, so obviously true evaluates to true. It's going to execute the body. Once it hits this particular line, it creates a variable n and gives it value 0. We then move down to this line, and what that's going to do is take n and increment it. Eraser. Come on. This line prints that particular variable out to the screen. So now this n was created inside the block that begins here and ends there. Right? I think we can all agree that the variable, the declaration of the variable, the int n part, was actually inside that block. So once that block ends, which means once you hit that particular line of code, Java thinks that you don't have any more need for the variable and will get rid of it. Which means that that variable n, you can use it any time you want inside, I think I need to erase all this. You can use it any time you want inside the block, but once the block that it is being created in ends, the variable disappears. So this line right here, Java will give you an error. As far as Java was concerned, you created the variable inside this block. It used it inside the block, right? It added 1 to it. It printed it out. Once that block ends, which is when you hit that closed curly brace right there, Java deletes that variable, and therefore that variable, as far as Java is concerned, doesn't exist when you want to go print it out. This is called variable scoping. Scope is when you scope something out, you're seeing what's visible. And the idea here is that this variable n is visible to Java inside that particular block and not visible outside the block. So anytime you create a variable, once that block ends, that variable is deleted. Java just automatically gets rid of it. Not quite garbage collection, but kind of, sort of. So we're going to talk a bit more about variable scoping. But the thing I want you to keep in mind is that anytime you declare a variable inside a block, when the block ends, the variable is deleted. In the case of a loop, it creates the variable inside the block. Once the block ends, the variable is deleted. Well, every time the loop loops around, Java considers the block to end. So after you finish all of this body on the first iteration of the loop, as far as Java is concerned, the body ends, or the block ends. Java deletes the variable, starts over, recreates it, adds 1 to it, prints out 1. Deletes it, starts over, recreates it, adds 1 to it, prints out 1. So this also would give you an error, because int n is defined within this inner block. And you can happily use it within the inner block, add 1 to it, print it out. But once you exit the block, meaning you get to this print statement, Java is going to give you a variable, like unknown variable error. I forget the exact error message. So let's look at this code. Here we have a for loop. And we're actually going to go through and trace through it. So first thing is the int I equals 0. That creates an integer variable I and gives it value 0. That's done once and once only. Now we're going to start going through the loop. It first checks to see if I is less than 3. Well, 0 is less than 3, so you're going to print out I is 0. The body of the loop has now ended. So we're going to add 1 to I. So I equals I plus 1. And we've incremented it. We then check to see if 1 is less than 3. It is. So we're going to print out I is 1. Body of the loop ends. We're going to add 1 to I. I becomes 2. There we go. 2 is less than 3. We're going to print out I is 2. The loop ends. I is incremented. We then go to I is less than 3. Well, 3 is not less than 3. Right, it's equal to 3, but it's not strictly less than. So the Boolean condition is false. We're going to no longer execute the body of the loop, and we're going to print out all done. And that's essentially how a for loop works. A couple of things to note. If you say int I equals 0, you'll see a lot of for loops like that, and you say I is less than 3, we're going to count 0, 1, and 2. We will never execute the body of the loop when I is equal to 3. And this is like indexing in an array. No, we haven't seen arrays. Strings. If you have a 10-character long string, its character indices 0 to 9. Well, here, if you have a loop that starts at 0 and goes up to but not including 3, you're going to go 3 times, 1 at 0, 1 at 1, and 1 at 2. In particular, so we talked about the scoping rules. Let me go back a slide. Oh, this is going to take a while. We talked about the scoping rules for ifs and whiles. When we declare it inside an if or a while, it's not visible outside the block. Right? Here, this is going to cause a problem. Well, going through this animation very quickly, blah, 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 blah. At this point, meaning once we're all finished, I is also no longer visible. Even though, I mean, if you actually look at the way the program is written, the block starts there and ends there. But as far as Java is concerned, when you declare a variable in a for loop like that, Java considers it to be inside the block. So even though I say for int I equals 0, and yes, technically that's outside the curly brace, Java considers that to be part of the block. So when we're all finished, I is going to disappear. The other interesting thing about a for loop is a for loop does not delete the I after each iteration. I'm going to get back to some of that. That's sort of getting into more detail than I want to get into this point. But the thing to keep in mind is that at the point we say all done, we could not then print out the value of I. Java knows I is no longer needed, or at least it thinks I is no longer needed, so it's going to get rid of it. Okay. So we've talked about ways to convert for loops into while loops. If I had this particular for loop, int count for count is equal to 0, count is less than 10, count plus plus, print out count. That's going to print out the numbers 0 through 9. I can directly translate that into a while loop. Int count, that's the line above. For count is equal to 0, that's the init that's done once and once only. While count is less than 10, I'm going to first print out that value and then increment it. And what that will do is print out the numbers 0 through 9. Right, and those are the two parts that are equal. So that can be translated exactly. Those two things are the exact same in Java. So here, notice that we've declared an integer variable int count equals 0. And that's a case when you can't exactly translate this from a for to a while. So this is probably the most direct translation, right? Again, you have the for init part first. You have the blue is the Boolean condition, green is the body, magenta is the increment. It would also print out 0 through 9. But the difference is, in a for loop, when you declare an integer variable there, Java gets rid of it when you're all finished. Here, this int count is declared, so somewhere in here we have blah, 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 main, right, string args. That int count in the while loop is declared inside the main block, which means Java won't get rid of it until we hit the close thing for the main block. Which means that at that point, well, at that point, that int count is still declared. The reason being is that for a for loop, when you declare it as part of the for init, Java will get rid of it when the for loop completely finishes. In a while loop, if you declare it before a while loop, it's still hanging around when the while loop's done. So for the most part, we can translate a for to a while, but not always. All right. Okay. Come on. Come on. There we go. So, for those of you who aren't familiar with Dubai, it's pretty much located on the equator, or like 10 feet there off. Okay, not really, but it's really close and it's really warm. So there was this big construction, and it's also an extremely oil-rich country and tremendous amount of wealth. So they were building this really big kind of slope structure in the desert, I might add. And you'll notice that the size of it, you can actually see, this is probably a 15-story building behind it. And you can actually see that's a car ramp, and those are some really vehicles. It's a pretty big structure. And it turns out that in the middle of the desert in Dubai, they built a ski resort. It burns some huge amount of oil to actually keep this thing at, just a sub-freezing temperature, and then they have snow machines.
This is a crime against humanity.
So this is called, I forget, there's actually a name for it. It's like Dubai Resorts. And people will fly, I assume not from, places with real ski resorts, but will fly here and pay some huge amount of money to go ski in the desert.
Actually, my roommate from Dubai.
Really?
It's really cheap. It's like for $100 for a whole day for 1 year.
Really? That's like cheaper than Wintergreen. It probably just as good too. Oops, I'm sorry, did I say that? So yes, goes to show you that with enough money, you can build pretty much anything, anywhere. So we've talked about indexing. When we are indexing strings, characters into strings, it all starts from 0. First character is index 0. The last character is index n-1, where n is the length of the string. So a for loop would look like this. For I equals 0, I is less than 10, I plus plus. In particular, that's going to execute the body of that for loop, indicated by the ellipses, 10 times, with the values 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. If we wanted to go 1 to 10, the for loop would actually look like that. For int I equals 1, I is less than or equal to 10, I plus plus. This would allow you to go from 1 to 10 in your for loop instead of from 0 to 9. Depends on what you're looking for in the program, but a lot of times, more often than not, you'll be using this form that goes from 0 to 9 as opposed to this form. So we can stick loops inside loops. Inside the body of a loop, we can stick anything else we want. In particular, we can stick yet another loop. So, so here we're going to declare two variables, m and n. For I equals 0, I is less than n. So at that point, n is 3. I think we're on pink today, right? That's 3. And m is 2. So what it's going to do is it's going to execute this outer loop 3 times, right? Once when I is 0, once when I is 1, and once when I is 2. For each time the outer loop is executed, we're going to execute this inner loop twice, which means total that inner loop is going to be executed 2 times 3 or 6 times. In particular, for the first it executes the outer loop, and that line right there says I is 0. It's then going to execute this loop twice, and both times it's going to say j is 0, j is 1. This loop finishes. It then moves to the end of the outer loop and starts the outer loop all over again. That time it increments I, and I becomes 1. And then for this iteration of the I loop, the j loop runs twice. J is 0, j is 1. Then the last time I is 2, and j is 0, and j is 1. This is called nested loops because you've nested one inside the other. And essentially, if you have nested loops, if the outer one runs 3 times, and the inner one runs 2 times, this body here is going to run a total of 6 times. So you multiply them together. We're going to see a couple examples of this. I have a problem aptly called the 4 hobos that's coming up that actually is going to illustrate some of this. So notice now the difference is that I've said n is equal to 4. And instead of j is less than n, or m, I've said j is less than I.
So really you're not using
M. Yep. So I could actually completely get rid of it. Well, mostly get rid of it. So it's going to execute this outer loop, again, a total of 4 times, right? We're going up to n, and it's 4, so it's going to execute when I is 0, I is 1, I is 2, and I is 3. When I is 0, this inner loop says, do it while j is less than I. Well, 0 is never going to be less than 0, so when on the first time that we get to that loop, we're never going to actually execute the body. When the Boolean condition of a loop is initially false, this applies to both while loops and for loops, it will never actually execute the body. So we get to this point, I is 0, j, which has just been created, is also 0. 0 is not less than 0. That evaluates to false. It won't execute the body. We go around again and start executing the for loop, I is 1. Well, now, again, it creates j is equal to 0. It's going to do it while j is less than I. 0 is less than I, so it's going to do that inner loop once. We go around again. I becomes 2. We execute the inner loop twice. And then when I becomes 3, we execute the inner loop 3 times. So here you'll notice that the inner loop executes a total of 6 times. So you can't really multiply, I and n. But the idea is that the higher that I goes in terms of, each successive iteration of the loop, the more times that this inner loop is going to be executed. Okay. How are we doing with for loops? Come on, you can do 100. Yes. I've had that happen. Okay. So to a certain extent, that's what I expect at this point. We're going to go over a number of examples of for loops. I'm going to get to something else first. We're going to go over a number of examples of for loops, and I think that'll actually help solidify it a bit more. You're also going to see for loops in this lab this week is while loops. Next week it will be for loops, and I think both of those will actually help. Okay, so, nepotism, as I choke on a cough drop. We promote family values here almost as often as we promote family members. Not so good? Motivation. If a pretty poster and a cute saying are all it takes to motivate you, you probably have a very easy job, the kind robots will be doing soon. This is one of the ones that's hanging up in my office because it was voted pretty highly. And I feel comfortable hanging it up in my office because, well, if robots start programming computers, then I'm out of a job and I lose the office. Misfortune. While good fortune often eludes you, this kind never misses. Persistence. It's over, man. Let it go. So when I was in grad school, I was had this one person I was about to be a running partner with, and I didn't realize quite how fast she was. Like she's like, yeah, we should run together. She like won the Philly Marathon the next year, and I like came in like 20 hours later. So every time I see this poster, I think of her, and it's always rated really highly, but they don't actually sell it in poster form, which really gets on my nerves because I think it's a great poster. They sell like note cards and postcards. Anyway, go figure. Okay. We've seen 2 of the 3 types of looping controls in Java. We've seen while loops. We've seen for loops. We're now going to talk about do-while loops. And in particular, once we finish with do-while loops, we have 1 or 2 slides of miscellaneous stuff. We are then going to start, I'm going to give you a lot of examples that I think is going to help solidify a lot of it. So if you're feeling a bit iffy on some of the stuff like half the class that was a bit iffy on for loops. That's fine. I don't expect you to fully understand for loops and be able to program in them yet. This is the syntax for a do-while loop. Do action while expression. Again, action can be a single statement or a series of statements surrounded by curly braces. And here's our for loop. Our flow chart. In particular, you'll notice that unlike a while loop, it first executes the action and then it checks the condition. Whereas in the while loop, it first checked the condition and then did the action. So the first thing this does is it does the action and then it checks the expression. It will then do the action again and check the expression. And keep doing the action while the expression is true. Right. So it executes the action. If the expression is true, it executes it again. If the expression is true, it executes it again, etc., etc., etc. This keeps going until the expression is finally false. And then, of course, it happily goes on to the pretty white dot. Right, we talked about that. So consider this, this code. Enter a positive number. We read in a number through our scanner. And then we have this as our body of our do-while loop. So first, this here, the first number was read in. It's going to find out the digit. And the digit is going to be the rightmost digit in the number. If you enter 325, that's going to be 5, right? Because it divides it by 10. 10 goes into 325, 32 times with a remainder of 5. We then print out the digit, so we print out 5. And then we divide the number by 10. Remember, that's integer division. So 325 divided by 10 is going to be 32. And it says, while number is not equal to 0. Well, 32 is not equal to 0, so we're going to go around and run all through this all again. That line is going to extract out 2, and it prints out 2. And then this line here, we're going to take 32, we're going to divide it by 10 and get 3. 3 is still not equal to 0, so we're going to loop around again. 3 mod 10 is 3, because it goes in 0 times, so 3 left over. So we print out 3 on the second line. Now on the third line, we say 3 equals 3 over 10. Well, 3/10 is obviously 0.3. Integer division, it rounds it down, it becomes 0. This now is false, and the program will continue on that way. So pretty similar to a while loop. The difference is that it first executes the body, and then it checks the condition. A while loop first checks the condition, then executes the body. Oh, right. So basically, it's going to print all the digits of a number, starting with the least significant, meaning the ones, all the way to the most significant, which is, in this case, the thousands. So we could also have somebody guess a number. As a fun and exciting game, the computer magically picks a number, and you keep doing it until you get the number. So for somehow, at some point, a number was entered into the number. It's some integer variable declared. Maybe it's hard-coded, at which point it wouldn't be much of a guessing game, right? Or maybe it was entered by somebody else when you weren't looking, or maybe it was randomly chosen. So what this says is it first asks you to enter your number. It reads it in. And then it's keeping track of how many times you actually guessed. And it keeps looping around while you have not guessed the number, meaning while guess number, which is what you've entered, is not equal to the answer number, which is over on the right there. Right. I don't feel like guessing the number now, so take my word for it, it actually works. So when do you use which? Well, I mean, a lot of which one you use when is we're going to see as we get more experience programming. But the thing to keep in mind is that if the condition is initially false, if the Boolean condition is initially false, a while loop will never execute the body the do while loop will execute it once. For example, consider this, while false. First thing it does is it checks the condition. False evaluates the false. It's not going to execute the body and continue on afterwards. A do while loop first executes the body and then checks the condition. So even though the Boolean condition is false, always false, a do while loop will execute the body once. And that's part of the difference between them, is whether or not you want the body. Sometimes you always want the body to be executed at least once. That's when you'd use a do while loop. Sometimes you never want the body to be executed if the condition is false. Then you'd use a while loop. Right. Never execute and executed once. So as I said, they're all kind of equivalent. For the most part, there was that one way that you can't change a for into it. There actually is a way to change it, but we haven't seen that yet. And if you have a do while loop, so it's going to do action while some expression is true, you can translate it into a while loop this way. You have to create an additional Boolean variable. I'm going to call it flag, and initially set it to true. And this is going to say either, so while either the while expression is true or the Boolean variable flag is true, I'm going to execute the body of the loop. In particular, I still do the action, right, which is here. But I'm also going to set the flag to false. So the first time it checks the expression, the while expression, this is, of course, the lower loop. The first time we check that expression, flag is true, right, because it was just created there. So regardless of what while expression is, this will execute it will enter into the loop body. Flag is true, therefore the or must be true, regardless of what while expression is. We then set flag to false. So the next time we go around, it's while expression or false, so it just depends on while expression. So this is how the program would exactly translate a do while loop into a while loop. Other than the fact that you're using up an extra variable, it's pretty much exactly the same thing. Okay, how are we doing with do while loops? This is like 3 days in a row that the clickers have worked. I mean, not consecutive lecture days, but 3 consecutive days that I've tried it and the clickers have all worked. I'm actually starting to think that it might be worth it. Okay. Okay, so I'm seeing from the previous one, it seems a bit more understanding about do while loops than the others. I will be upfront about the fact that do while loops are not used quite as much as while loops and for loops. I want you to understand all 3 loops. Primarily, you're going to be focusing on while loops and for loops. While loops you're going to see this Thursday. For loops you're going to see the Thursday after spring break. On that note, I'm out of time. I'll see you all on Wednesday.